Okay, welcome back to EE 203 Geometry. Today I thought it'd be a good idea if we could review some of the things we've gone over with triangles for those people that are struggling with that. So we're going to look at a couple of the things or problems relating to triangles, and then we'll take another look at maybe some problems that involve proofs with triangles. So just to sort of recap, we went over this earlier this week. We talked about, hey, if we have a triangle, the sum of the interior angles of a triangle is 180 degrees. We call that the triangle sum theorem. Angle 1 plus angle 2 plus angle 3 equals 180. And that's probably a concept you guys used in middle school a lot to set up and solve problems. But more importantly, it's in this unit or this chapter on parallel lines, because we can prove this using parallel lines. And we basically set up the proof this way. We said, all right, if I look at the vertex of angle 2, how many lines could I draw through that vertex that would be parallel to this opposite side? Of course, the answer to that is just one. So if I constructed a line that was parallel to that, we just created two adjacent angles to angle 2. And now when we look at this, I want to prove angle 1 plus angle 2 plus angle 3 equals 180. If we're setting this up in a two-column format, statements, reasons. In this case, I don't have anything given other than the diagram, so we wouldn't put given, refer to diagram. But if I look at this, I've got parallel lines there. So we're going to, basically, if I look at what we're trying to prove, I need to get an equation that involves some angles adding up to 180. And the only types of things that give us that other than parallel lines, or not parallel lines, but other than supplementary angles, two angles that add up to 180, is we said we could use the angle addition postulate to add some adjacent angles together to get the larger angle that they create. If I look at this, if I added angle 4, angle 2, and angle 5 together, it's going to equal the large angle that they make, which is 180 degrees. So I can get this equation, angle 4 plus angle 2 plus angle 5 equals 180. That's the angle addition postulate. Now we're going to throw in the fact that, hey, we've got parallel lines. Well, we said with these parallel lines, if I look at this, I can make the alternate interior angles on the left-hand side and alternate interiors on the right-hand side. And alternate interior angles are, if the lines are parallel, then the alternate interior angles have to be congruent to one another. So my next statement here is going to be 2. Angle 4 is equal to angle 1. And angle 5 is equal to angle 3. Reason for that is parallel lines imply alternate interior angles congruent. Now we see with these two statements I can substitute angle 1 in place of angle 4. I can substitute angle 3 in place of angle 5. Now I get the line angle 1 plus angle 2 plus angle 3 equals 180. What did we just do? Substitution. So that was one of the theorems we looked at, the triangle angle sum theorem. Whoops, lost my eraser. It's way over here. Hold that thought. So aside from the sum of the interior angles being 180, the other thing we looked at was exterior angles. And with exterior angles, now we're going to look at a triangle. I'm just going to draw an arbitrary triangle. And an exterior angle is an angle formed by extending one side, and it's going to create an angle with that extension and one of the sides of the triangle. So if I extend this side this way, I have an angle that's outside the triangle, and then I have these interior angles. So let's first label the interior angles, 1, 2, and 3. Now I'm just going to call this angle on the outside angle 4. Now we just went over that, hey, the sum of the interior angles is 180. Can I use now the exterior angle theorem? And the exterior angle theorem basically says if I have an exterior angle, which in our case right here is angle 4, then it's equal to the sum of Now some books say some of the two remote interior angles, some books say some of the two non-adjacent interior angles, and I've seen some that say some of the two opposite interior angles. They're all basically describing the same thing. If I said it's non-adjacent interior angles, angle 4 is adjacent with angle 1, same vertex, common side. It's not adjacent with angle 2 or 3. So I can say angle 4 is equal to angle 2 plus angle 3. Again, that's a theorem because we can prove this. So if I looked at this, if I was setting this up in a two-norm proof, I've seen this proof done a couple ways. I've seen it done with parallel lines. And I've seen people make a parallel line here to this side, and then they talk about the relationship between this angle and angle 3 and this angle and angle 2 with the fact that the lines are parallel. But to me, this theorem seems a lot easier to prove based on the fact that we just proved angle 1 plus angle 2 plus angle 3 equals 180. So that's what I would start off with this. And I'd say, hey, angle 1 plus angle 2 plus angle 3 equals 180. That's the triangle sum theorem. Now, 2 and 3, I at least got this part of the equation sort of on the board with some other stuff. I need to involve angle 4. If we look at angle 4 and 1 are a linear pair. Linear pairs are supplementary. But more importantly, I could use the angle addition postulate to say, if I add these two adjacent angles together, I'm going to get the large angle that they create, which is 180 degrees. So now I can say angle 4 plus angle 1 equals 180. Angle addition postulate. Again, we put something down in a proof. You want to put it down, use it, or do something to it. So in this case, this expression equals 180, this expression equals 180. So really what I'm going to do is wherever I see 180, I'm going to substitute in angle 1 plus angle 2 plus angle 3, because that's what it equals, 180. So now I get the equation angle 4 plus angle 1 equals angle 1 plus angle 2 plus angle 3. We just did substitution. Now we're pretty close. We got angle 4 on the one side, we got 2 and 3 on the other side. What do we need to get rid of? The angle 1s. Now if I wanted to be technical about this proof, this is where we're going to throw in that one property that we're like, hey, we don't use that property that often, but I could throw down here angle 1 equals angle 1. If you remember back, what lets me say anything is equal to itself, whether it's an angle to an angle, side to a side, or a number to a number. That is the reflexive property. And now, what can I do with these two equations? I'm going to use the subtraction property of equality. And in a sense, this is really what we're doing here. Subtract those equations. So subtract what's on the left. What happens to the angle 1s? Cancels out. I'm left with angle 4. Cancels out. I'm left with angle 2 plus angle 3. And we just proved the exterior angle theorem. So let's take a break, and I'm going to put some problems up on the board that we can go through that'll just be some angle addition, or I'm not angle addition, it'll be some exterior angle problems, and there'll be some problems involving the sum of the angles of a triangle. Okay, let's take a look now at two triangle problems, one dealing with the sum of the angles inside of a triangle, one dealing with that exterior angle theorem. You've got to remember, the sum of the angles of a triangle add up to 180 degrees. So whether it's just looking for a specific angle, whether it's solving for x, whether there's a couple angles that involve that have an algebraic expression, we're still going to set up the same equation. We're going to say, hey, these three angles have to add up to 180 degrees. So take your pick, 40 degrees plus 65 degrees plus 5x.
Can I have your attention, please, Mr. Fizicaro? Please call the main office. Thank you.
Equals 180 degrees. I hope Mr. Fizicaro calls the main office. But back to what we're taking a look at. Now I want to solve this for x, combine like terms. We got 40 and 65. Add those two together, we get 105. Still have the 5x, still have the 180. Solving for a variable, get the variable by itself, isolate the variable, so I'm going to move the 105 to the other side, do the opposite operation. So in this case, we're going to subtract 105 from both sides. They cancel, leave me with 5x equals 75. After we've isolated the variable, we want the coefficient of the variable to be 1. So we're going to divide both sides by 5. And we get x equal to 15. Again, this could be a problem solved for x. It could be a problem where if I had this label, triangle ABC, find the measure of angle B. I mean, if this was a case of find the measure of angle B, we would even have to solve for x. But if there were a couple angles in there that had variables in it, then we'd have to plug it back in when we were done. Now the second problem over here, this deals with the exterior angle theorem. And when we went over that, the exterior angle of a triangle is equal to the sum of its two, and we used a couple words here. We said it's two remote interior angles. Some people looked up that definition and said it was equal to the sum of its two non-adjacent interior angles. Some people said the two opposite adjacent angles, or opposite interior angles, I should say. This is an interior angle that it's adjacent to, opposite ones it's not adjacent to. So we can set this up and say the exterior angle is 125 is equal to 90 plus 7x. And we're solving this for x again. So again, get the variable by itself, subtract 90 from both sides. That cancels. We're left with 7x. 125 minus 90 leaves us with 35. Divide both sides by 7. And we get x equal to 5. So there's an example of sum of the interior angles, an example of the exterior angle theorem. Next we're going to take a look at, I believe, some relationships with angles in polygons.